Okay, question 5 is asking us to complete the square. So that's a nice little bit of AS maths. So pretty routine. I'm going to take out a factor of 2 from the first two terms. Then complete the square of this bracket. And to do that, I'm going to divide this value by 2. Take away the square of it. And then I'm going to multiply this 2 back into the square bracket. So 2 lots of the square bracket, take away 2 and add on 9. So that collects together at the end to give us positive 7. So 2 lots of x plus 1 squared plus 7. Part B wants us to sketch the curve of this. This is going to be a stretch and a translation of an x squared graph. We know it's going to go through 9 on the y-axis, and it's going to have a vertex of -1, 7. So a positive quadratic crossing through 9 on the x-axis with a vertex of -1, positive 7. So it doesn't actually intersect the x-axis. There would be no solutions to this curve, or to this equation, sorry. Points of intersection with the coordinate axes and the coordinate of the turning point. So we've got both of those marked on there. A bit of a tricky question, I think. We've now got 21 divided by the function f of x that we had earlier. If you remember what f of x looked like, it was a quadratic, positive quadratic, with a vertex at -1, 7. So the minimum point of this vertex or the range of f of x we could write down, f of x's range might be helpful, is greater than or equal to 7. So the number that we're substituting in to here is only ever going to be 7 or more, but it can grow as much as we want. And if you kind of think about what is going to happen, is we're going to be substituting in bigger and bigger and bigger and bigger and bigger values of f of x into here. So as f of x increases more and more and more and more and more, we're going to have 21 over a bigger and bigger and bigger and bigger number. And obviously, the bigger we divide by a number, the smaller the overall answer will be. So h of x, as we divide by bigger and bigger numbers, is going to tend to infinity to 0, because f of x tends to infinity. So as f of x tends to infinity, h of x is going to tend to 0. And that's going to happen for the negative infinity values as well. So as f of x tends to positive or negative infinity, h of x is going to tend to 0. So that's going to be the smallest value that h of x can be, 0, but not equal to. It's never actually going to get to 0 because it's never actually going to get to infinity. Now what about the other end? So we now know that, well, we already know, we've already said that the smallest value of f of x that we can put into here is 7. So surely that's going to give us the biggest value of h of x. So we're going to have 21 over 7 will give us the largest value, that h of x can be, because that's going to be the smallest number that we can ever put in here. We can't put a number smaller than 7 in, or we can't get a number out smaller than 7 from this part of the function, which means 21 over 7 is 3. So that is going to be the biggest value that h of x can take. It will be able to equal 3 this time because we can get a value of 7 out. Okay, C part 1's quite an interesting question. It looks similar to both the completed square form, which if you remember was this, plus 7, and it kind of looks like this one as well. Now, at first glance, I thought we were going to be transforming from this graph, but this plus 4x here means we're not transforming from this graph, we're transforming from this graph. But if we were transforming from this graph and it looks like there's a translation in the x-axis, you'd think that this would be a 4x with a bracket. And there must have been that, but they've then expanded that bracket and brought the 9 in to kind of simplify it all again afterwards. So that's the confusing bit here. There must be a translation in the x direction because of this bracket here. So that has to be true. We shouldn't worry about the fact that it doesn't look like it's happening here. It must be happening because of this bracket. So we must have had a translation to get this happening, a translation in the x direction, and it'll be 2 units to the right, so positive 2 units. So if you remember with your x translations, it's the opposite of what the sign is. So in other words, we've done f of x minus 2 to get to this point from here. So if we do this now, if we work out f of x minus 2, we can see what's going on with this 4x term that I was mentioning earlier. So it will be 2 lots of x minus 2 squared, which we want, that's important, plus 4 lots of x minus 2, plus the 9. And now, as I said before, they must have expanded this and incorporated the 9 to get back to that 4x. So that's going to be plus 4x minus 8 and plus 9. Which is going to be plus 1. So that nearly looks like this now, but how is it different? Well, the end terms are different. And if you change the end term value of a graph, just the end term, that's when it moves up and down vertically in the y direction. So that must have been what's happened for the second transformation to get to this g of x function. So how many have we moved it down? We've moved it down 4 units to go from plus 1 to minus 3. So it's translated 4 units in the negative y direction. And then we can hopefully see that if we do that transformation to the middle transformation, so if I just take 4 off, that will be 2 lots of x, take 2 squared, add 4x, add 1, and then take away that new 4, which will get us the minus 3 that they've got at the end of theirs, which is g of x. So how it says describe fully the transformation that maps it from here to here. And it's suggesting that there's only one, so we need to say that that's kind of happened as a vector. So the overall transformation is a translation by the vector to negative 4. So it's gone 2 right and 4 down.